First of all, a very warm welcome to one and all. My name is Vishal, and we are conducting a webinar on astronomy. Webinar will be conducted by Soham Deshpande. Now, next part of the this event webinar will be handled by Soham. Soham.
Yeah, I'm here. Good evening, all. Do we need to wait for a few minutes or to let everyone come?
Yeah, let's start the meeting. And guys, any questions regarding to the webinar, kindly put your questions or queries or any types of questions in the chat box, so accordingly we can reply to your questions. Soham, yeah, you can start the thing.
Okay, sure. Give me a minute. So please do let me know if you see my screen or not. Yeah, is it visible?
Yes, Soham, the screen is visible.
Hello. Okay. Okay, great.
Yeah.
Okay, guys. So good evening. I'm Soham here. And as the webinar goes along, I'll tell you more about me and this particular Astronautic Institute, what we have undertaken and all. And at the end of the session, also I will take the questions. If you are having any questions, doubts, or if you think that this is different, or you have read something else somewhere, you can just raise your hand or type that in chat box. Vishal sir will let me know, and I'll tell you more how to go deep into astronomy and what is the exact benefit of yours in all these things and in the future as well. So yeah. So yes, I'll start now. I'm starting the slideshow. If anything goes different, let me know, please, Vishal sir.
Yes, sure, so.
Yeah. Yeah, I hope the screen is visible now. The slideshow has I have put on the slideshow. Yes.
Yeah, screen is visible.
Yeah. Okay. Great. Okay. So, guys, we are also on YouTube Live, and many people are also watching us apparently. And slowly, we are going to increase this strength on a very large scale, and we are going to function also in many different, not just institutes or universities, but also states and different cities, major cities across India. So basically, today's webinar will be on astronomy, a webinar on astronomy, and our three main topics will be future of Indian astronomy, cosmic power, or you can also describe it in cosmology or anything else, and dark matter. So I am Soham Deshpande here, and our founder Deepak sir is also there, Dhanush sir is also there, co-founder, and Vishal sir is also there as a great helping hand. So let's start. I'll give you a small intro about me, and I hesitated to add this slide, but I was told to do so. So yes. So yeah, a small intro on me. I'm from Maharashtra, and I'm just an astronomic enthusiast, just like you all. Because as you people have joined here on the evening of a Saturday, that too also weekend, that means that you have some potential to do into astronomy and do something in the future as well. So just like you, I'm also an astronomy enthusiast, and I have cracked National Space Olympiad NSO by Japanese Space Agency. I have done some courses. You can read the names, and I'm having some hands-on experience on Cube satellite. It was a femtosat. If you want to know at the end of the session, you can ask me that what type of satellite it was and how the experience I had. on the Cube satellite or femtosat. I'm a ISRO quiz winner in 2022 during the Space Week, and I went to ISRO Bangalore headquarters there as a felicitation program. I am having some records in satellite launching. It was a collab with a different private space agency from Chennai itself, and we did some. We together did some initiative, and I was having a great experience there to work on the Cube satellite there and make a record there. So I headed, being a part of Lakshya Space since last 2 or 3 years. I have been head of 3 different intern batches, and I have guided students, 3 batches of students regarding CubeSats and even drone technology. I am currently having a post of team lead electronics, junior project associate and researcher with collaboration with Lakshya Space. You can also look that name or my name on the website of Lakshya Space. You will find that my name under the our team of CubeSat domain. Okay, so that's enough about me. And I just want to tell you all that this is not a lecture or this is not a workshop kind of thing. This is like an interactive session. So the first sessions which we are going to have, the Astronomic Institute, which is going to have the first sessions, those will be like particularly like this only. But coming days we'll be having more good, guest lectures. We'll be having certificate programs and many more. I'll tell you more about how we are going to offer and make a student community all across the country, and how it is going to be unique than other student communities or other edtech platforms in space. So our parent company is Lakshya Space, and Lakshya Space is also working on many other programs just like drone technology, Cube satellite technology, and rocket propulsions and every kind of things. Okay, so let's go how it is. Let's start our session, and today I'm going to tell you about these contents which I have already just previously told you in the slides. And next, let me tell you all that I will also be taking some quiz questions and discussion programs on cosmology. Okay, and I want you all to collaborate and interact with me. That will be the most perfect gift for me for this session. So yeah, let's start our program without any further more delay. So introduction to dark matter. So now what is exactly dark matter? Let me tell you a brief overview. What is dark matter? Okay. So basically, let me start from the scratch that how many of you might know about dark matter, because these are hypothetical things. And since the very start, whenever a person says to me that he or she is having some particular interest in astronomy, he must be having some base of dark matter or extraterrestrial life form like aliens and all, and black holes. So these are some common topics between every astronomy enthusiast. So that is why I choose to take this up. And let me start from dark matter. Let's go into the deep theoretical part, a bit theoretical part or conceptual part of dark matter. So what is basically dark matter? Dark matter is nothing but the matter which you can't see. Okay, it's just literal. The meaning of the word is dark matter. That's just literal thing of that. So let me tell you how it's possible. So you can see in the pie chart there that the universe has been clustered into 3 parts. Baryonic matter, you can see on the right hand, right? Baryonic matter, and dark energy. So let me tell you what it is. Okay, so baryonic matter, whatever the normal matter you are seeing around you, the trees, animals, your friends, whatever you are made up of, basically universe, nebulas, clusters, supernovas, supermassive black holes, planets, everything. Okay, so those all things are normal matter. That is made up of baryonic matter, or even it reacts or it behaves in a Newtonian manner. Okay, it is having some Newtonian science applied to it, which we call classical mechanics. Okay, so that is normal matter. It is, so whatever the things which you are seeing around solar systems, galaxies, clusters, or super clusters, like other super universe or something observable universe. So these are things which you can see. These are all normal matter. Okay, so this particular normal matter, so many big things which are there, right? Some nebulas are more bigger than some galaxies as well, we have heard of, So these all things are only consisting of 4.6%, or to be approximate 5% of the normal universe. The whole universe, which is 100%, the whatever you are seeing around yourself, that is only 5%. Okay, so just imagine, we don't know anything of the 95% of the universe, we are unknown about. Okay, so there are so many things to discover in universe till now. So yeah, let's go into more things. So what is basically now normal matter, you know of. Baryonic matter, you get it. What is baryonic matter? It is made up of, it is a just normal matter, you know, atoms, subparticles, quantum mechanics, everything, whatever reacts, Higgs boson, scalar bosons, and all kind of things. So these are all baryonic matter, normal matter. Okay, now let's go to the furthermore topic. Let's just take the dark matter thing. So now dark matter, it is made up of 23%, or it is actually scalable from 23 to 30% of the universe. So it is having a composition of non-baryonic matter as well. Okay, it is also known as, like, these are chunk of some things. It actually these are all known as also, this is also having a different name of massive compact halo objects, means machos. You can see there in the third question, I have described it at macho, right? So what is basically now all these things? What the hell is going on here? So basically, dark matter is that particular matter which doesn't react with the normal matter. It doesn't react with normal atoms, subparticles, photons, atoms, or electrons, neutrons. It doesn't react with those. That is why it is very, very hard to get the interactions, day-to-day interactions going on between this matter and a different kind of matter. Okay. Now, as we can see that normal matter is there, we also know that there is something called as antimatter. Right. So antiparticle or antimatter doesn't exist in the observable universe, or the universe we know of around us, because if no antimatter exists, then it will instantly annihilate with the normal matter and will make such a big boom. It will be more powerful than 15 hydrogen bombs, right? So this is some statistic you can just get it. This is just some conceptual things you can understand. So the dark matter doesn't react with any other thing. You know, we all learn chemistry, right? Hydrogen, we all know HCl and all kind of things. So we all know that how carbon monoxide is converted into carbon dioxide, just Cu and CO2 in contact. So these all things just react with each other and make more complex atoms. Same thing in our sun, hydrogen, nuclear fission reaction goes on, right? So there the particular thing goes is like hydrogen converted into helium and then it annihilates. So that is how it goes, that chemical reaction composition of the chemicals goes on, right? The most basic elements in the universe is hydrogen and helium itself, but that those particular things reacts, and it also comprises of nuclear fission and fusion reactions. But dark matter doesn't react with any damn thing. So that is how we are not knowing any solid proofs of of dark matter is not there. Then how do we know that it doesn't exist? We are saying that it doesn't exist. We don't know how it's there or something. We don't have any proof. Then how are we saying that it's there? So basically, let me tell you that our solar system, right? Solar system is having all the planets. Sun is there in the middle, right? And around the planets there are moon goes on, right? So all these things, we have the mass comparison which we have did on a standard supercomputer by a scientist. It came out to be 5% exact. Okay, so that is why we know that there is something more bigger than this particular thing, because it is providing mass to some objects, to these objects, to the normal matter, it is providing mass. So we do know that yes, there is something which is providing mass, but we don't know exactly what it is. So that is why we named it dark matter, right? So now you have got a basic overview or vivid overview of what this dark matter is all about. Now, how this is made up of? So basically, it is actually what scientists say, it is a normal term, interacting massive particles. So these are some overviews. You will get it more ahead. I will not say everything in just one slide. I'm just telling you in a story manner so that you will make it, or you will find it more interesting to understand and take an interest in this. Okay. So let's go to the next slide. So now you have got what is the concept of dark matter. So now what we have done to locate this dark matter, what we have done to know more in the theoretical chemistry, or theoretical physics part, and the quantum mechanics or quantum chromodynamics to understand this dark matter, right? So this is a particular experiment which is done by university of many Ivy Leagues and many universities came together to do this. So University of Stanford and many other things came together and made a particular observatory, or to be honest, in a formal manner, detector. They made a detector, which is also called as dark matter interaction detector. Okay, its name is here, Lux Zeppelin. So you can find it. Now the thing is that, let me tell you how this was made and how huge prospect this is going on. Okay, so since you all know that how Higgs boson particle was, how Higgs boson was discovered actually. So we've used Geneva laboratory, which is there. We have used you know we have used all kind of particle accelerators we have used, which is there in Sweden and Switzerland. So LIGO we have used, CERN is there. So all these things we have used to identify or to know more about subatomic particles on a quantum level. Like so, the Lex Zeppelin detector, which is there. So this particular detector is used, or it was made in, I think, 2021 according to statistics, and it was actually they dynamited the whole mountainous region. They dynamited whole, and they made a hole inside the mountain, right? And that observatory, this particular detector, is inside the mountain, placed inside the mountains. And now let me tell you the overview of this particular detector. How is it made, and what exactly it is? Like, how can you detect the particle which is not interacting with any damn thing in the whole observable or the normal universe, right? So now this particular thing was undertaken because we have to make the grand unified theory. You might know about this. That grand unified theory is a theory which describes the universe in just one formula, one postulate, or one hypothesis. Because there are so many aspects. For example, let me tell you, in engineering, in the first semester, second semester, we are all having this kind of thing. If you have gone through this is like we get to know the overview, that what is the difference between quantum mechanics and classical mechanics, right? So there are different formulas and different postulates which are there for quantum mechanics and classical mechanics, because classical mechanics doesn't work in quantum way and quantum way doesn't work in classical way. It all contradicts each other, especially on the extreme parts of the universe. For example, black hole. That is why it is more interesting to go inside the black hole theory and all the Schwarzschild radiation, Einstein-Rosen bridge and all. So, anyways, let me tell you now. Let's get back to the topic of interaction, dark matter interaction. So, actually, there are two containers, right? So, there are two containers having each having 10 tons of liquid xenon, right? So, in two containers, and that container is made up of titanium metal. It is made up of titanium metal, and it is filled with liquid xenon, and it is having and all the prospects and all the complex things which are there, it is contained outside. It is having some radiation avoidance layer and all kind of things to the up. What you can see here inside the container, in the picture which you can see, inside there is liquid xenon, and the sensors which are there. These sensors, the golden part which you can see, it is like ultrasonic detectors and cosmic ray detectors and all kind of things are there. So we can know how is the origination going on, right? So let's say that we haven't got some very solid proofs, but yes, we have got some faint interactions in the mysterious particles inside the container. That liquid xenon is interacting with some of the transition while transiting from with the dark matter particles or the WIMP particles, to be honest, which I'm saying. So this is how it is going on, and this dark matter detector helps to protect it from the high energy protons, right? And and they actually, when this particular protons, when they interact with that particular liquid xenon, it is on the almost 99% the speed of light. So when they originate, when the real rays come from sun. So let me tell you that sun which is emitting the solar flare, the light and all kind of things, those solar flares or those cosmic rays, it is having every kind of frequency or wavelength which can be found in the observable universe. For example, gamma ray is there. There is ultrasonic ray. There is infrared. There is every spectrum of the part which is there, and it is harmful. Many of those are harmful. I will also tell you that how subatomic particles are created on the surface of the sun. For example, muon. Muon is a subatomic particle. Let's not go into there. It's a bit quantum mechanical part. I will not go in depth of that. But let me tell you that muons and all kind of particles which you can hear, quarks and all, it is all created inside the sun or on the surface of the sun, and then it is sent on the Earth. So to detect those kind of, those kind of quantum particles, we need such kind of things. There is also one laboratory in Japan, which is in Tokyo or something, near to Tokyo, inside same like this. It is underground. It is not inside mountain. It is underground, and actually it is called a super cameo candle. So super cameo candle is also like this only. It is filled with liquid xenon, and it was used to detect the neutrinos. Okay, so the neutrino part which is there, it is in subatomic particles. It is also part. It comes in the subatomic particle, and it is also a dark matter candidate. Okay, so dark matter candidate, I will tell you more about this. What is dark matter candidate and all kind of things. So yeah, this is basically the overview that what world have done till now to detect the dark matters. So we have got the faint, interactions or something, but it is not a very very solid proof, just like Higgs boson which we got, or the image which we got of black hole recently in last year and in this year as well. Clearer picture of the black hole with this event horizon telescope and all. So let's go to next slide. I hope I am clear till this particular slide. I hope everything is going on fine in the meeting. Vishal sir, can you
Yeah,
confirm? Can you rectify?
yeah, everything's going on fine.
Any questions till now?
Yeah, Soham, we have some questions in the chat box.
Okay. Let me come back to the main
Can I
window.
wait? I'll read it. I'll read it out.
Okay, go ahead, please.
How does dark matter give mass to normal matter?
Okay. How does dark matter give mass to normal matter? Now, this is a very good question, first of all. And for that, if you need to know this, then either you need to wait for it, or either you need to be that particular revolutionary scientist who knows the answer. But till now, what we have found in the basic interactions, dark matter gives the mass to the normal matter with there is something called as dark energy as well. In the next slide, I was just going to explain this as well. So what exactly, how this hypothesis goes now? Okay, so I need to tell you one more story on this particular thing. So what is predicted basically? Have you heard of, like, you have heard of Big Bang, right? So now there is one more thing which is called as Big Crunch, right? So let me tell you how this functions. So dark energy, what scientists predict, this is one of the hypotheses. There are so many theories, right? How universe got created. The Big Bang is one of the theories. There are so many more hypotheses. Big Bang is having most logic inside that theory, and we are having the proof of it, like CMB, cosmic microwave background. We are having the proof of it. So that is why Big Bang is worldwide known, right? Or the general theory of relativity. It is like it is worldwide known because we are having particular proof of it, like black holes, right? So same way we are having one hypothesis, like how this particular transition happens. So now we all know that universe is expanding, right? So now 68% or 65% matter which is there, it is dark energy. 30% to 25% or 23% that is dark matter. Remaining is 4.5% what is there, whatever it is there, it is normal matter. So now what scientists predict, one of the hypotheses is there that dark energy will convert more into dark matter, right? Dark energy will be the forming blocks of universe, and it will be transitioning in dark matter. Dark matter will be transitioning in normal matter, in the baryonic form, right? By interacting with itself, right? So those will make a more wider universe. Like for right now, it is only 4.5%. One day it will be 100%. As soon as it will be 100%, it will, the gravitational wave, the gravitational length will again start to pull itself inside backwards, and this will accelerate itself and will it will make that the density of the universe will increase and form into a big crunch, and the end of the universe will be there. Again from big crunch, one day it will again happen with Big Bang. So this is a cycle which is rotating. That is the same way why the pie chart was created basically. So this is how it goes. Like, this is a hypothesis how it goes. We don't have any proof that this is the only thing which is going to happen. Anything more? There are many more hypotheses and mathematical calculation hypotheses. Let me tell you this: these hypotheses or these stories which you are listening to, these are not bullshit stories, or which these are not like thought in air or something. Okay, so you need to understand that these are really very sophisticated theories, and every theory is having some mathematical calculation inside it. But these are all not having the exact point which is there. or there are many more fill in the blanks which are there inside the statement of the universe. That is why these all efforts, these are billions and billions. This particular experiment which is going on, this might have costed billion or 1.5 billion. I don't even know the price, but this might have costed 600 to $1 billion. So why are we spending so much of money? So to all these things we should know, and we to fulfill the, not just to fulfill the curiosity, but to know what is exactly going on. Because when we know, when we have a good knowledge of what is going on exactly around us, may it be physics, may it be classical physics, how a leaf drops, or how the while in the rainy season the leaf is green, while in the summers it fades away. So we are having a knowledge of it. That is why it is easy for us to understand everything the same way. This is how it goes on. So yeah, this is how it goes on. The first question answer is this. I hope it is a bit satisfactory. So yeah. Okay, so now let me read one more question, which is like, does dark matter affects in mass of an object? Yes, certainly. It affects the mass of the normal matter, because it interacts, somehow it interacts with the normal matter. It is actually like a cement which is holding every mass or every subatomic particle of the universe. So it is now, that it is acting like a cement. But how it is in mass? So what basically we think is of, there are some theories. Right now it is not proven, but there are some theories which say that Higgs boson is like a dark matter candidate. But in other, if you Google this particular thing, you will see that Higgs boson is a subatomic particle or a fundamental particle, because it is giving mass to every normal matter. So my answer will be also like this. I won't say that no, it's not, or yes, yes, it is. I'll say that the answer to your question is not dark matter, but answer to your question is Higgs boson. Higgs boson gives the mass to every object or every subatomic particle which is there, because it is itself like massless, and it gives mass to other heavier elements to interact with the normal matter, or to create different kind of compositions, chemical compositions in the universe. So yeah, this is how it goes. Next question is, why is xenon atom chosen? Can't you choose other elements? Well, this is quite chemical question. I'll say that xenon is having the perfect composition, chemical composition or radioactivity compositions inside the, in the liquid form. It is more cool, and it is like, more interactive, or to detect these things, because this has been proven while neutrino, because actually this was just like a permutation combination as well, because we all know that while Japan was doing the experiment on super cameo candy, we all knew that xenon was acting very good. Xenon was really having a good experience on neutrinos, and detecting neutrinos were really a big achievement for Japan, or JAXA. So that is why even this time NASA and other type of universities actually tried to do so, and tried to use xenon, because it was like a very permutation combination thing, that it might fail or it may succeed. So yeah, but xenon was a good indicator rather than choosing any other thing. If it's proven already, like it is having a good impact on subatomic particles. So if you get how the subatomic particle reacts, you can get more into further depth, that how it is formed, or how it get through. So yeah, this is how this is the answer to your question. Why titanium is used in this detector? So titanium actually doesn't react with, it is like a mediocre, it acts as a good element or a wall kind of thing between that liquid xenon. And titanium is also like it is a whatever the statistic you want, you can attach it from the outside. You don't need to put something in the depth of the container, which is like a 2 or 10 ton liquid xenon. So you can just get the output from the outside if you use titanium, or the statistic, using sensors and all with the outside itself. So that is actually a good conducting way, or the effortless way to use the titanium. And yeah, that is how it goes. I hope I have answered to your questions. Is it fine? I shall move ahead in the more session.
Any questions? Any questions? Anyone you have? After completion of this presentation, you can ping it in the chat box. Soham will answer accordingly. Soham, carry on with the next thing.
For sure. Okay. Yeah. So let's move ahead, guys. Okay, so I was on dark matter versus dark energy. Actually, I have told you just now between the questions that what is the basic overview of dark matter and energy. So let me tell you that it is like a cement. Oh, I have added this slide as well. So in the second point, you can see that dark matter acts like a cement and all in the universe. So yeah, and so dark energy is roughly having 68% of the universe, and it is like a very huge chunk of energy, hidden energy. Let me say. And that is why we are more curious to know that what is exactly there, what is exactly going on, and we don't even know what is exactly going on. And let me tell you that the formation of the black hole, or even the event horizon of the black hole, which are there, this is also a very good way to express that many scientists consider, or many theories consider, that black hole is like a is like a dark matter candidate. So now what is exactly, I have said this twice, that what is dark matter candidate now, because see, what is exactly what are the particles, or what are the particles which consist of dark matter? There are also some saying this neutrino might be the one who is consisting of dark matter. There are exions. Now exion is a hypothetical particle which is also made up of WIMP. Okay, so exion is also there. I think you might have seen this here in this slide. And there somewhere exam. Yeah, in the third question here, in the last word, exions or WIMPs. So exion is also there. Excites particle is a hypothetical particle. Neutrino is there, and dark matter is also in that list of dark matter candidate. The eligible person to be enlisted as a dark matter something. But it is not been proven that it is dark matter, but it is in the suspicious list or something. So it is like a suspect that whether it is or not. So yeah. Now this is how it goes. Dark energy, we don't know much, or to be honest, very 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 less about dark energy. Okay, so there are very less evidences for dark energies. There are some evidences for dark matter, and we are all trying to know that how dark matter is there. Right now we are all concentrating on different type of missions, and how the missions should be much more did on the sophisticated level, and how the humans can be shifted from one place to another, because Earth is having less time. That's what the statistics says so yeah, that is how it goes. And the image which you can see, this is like a nebula in infrared image, I think. So yeah, this is something, the cosmic beauty, which is these all things, every dot which you can see there, it is a galaxy kind of thing. Okay, it is a galaxy. Every smallest dot, even the faintest dot which you can see, it is galaxy. So these are all very makes an awe thing, which feels you makes you think that what is exactly there and all kind of things. And that is the same reason I think you all have gathered here. So yeah, next let's move to this next question. So yeah, I don't like lecture things. I get bored easily. So now let's go to the quiz time. So yeah, so now in the image which you can see here, right? In the image which you can see, this is a spectral class of stars. Okay, now this is a spectral class of stars. There are some things which are going on. You can see their white dwarfs, main sequence, giants, supergiants, Betelgeuse, which are basically red hypergiant stars and all. So Antares and all, Rigel, which is there in the Orion constellation, and Polestar, which all we know is the North Star. We also say it detects the direction in the north, and the y-axis scale, it is on luminosity, right? The saying that sun is having the luminosity number 1. Okay, one unit is sun's luminosity. Now we can compare the luminosity of other stars with the sun. So even this compare the masses of different stars or even black holes with the sun, because you might have seen this, like black holes. Some scientists say that, for example, I can say that the Sagittarius A star, which is there in the center of the universe, right? It is like for example, I will say a rough figure. I will take 100 solar masses. So 100 solar masses. What do you mean by 100 solar masses? So the mass or the particular object is having 100 times the mass of the sun. That is called, that means that object is having the mass of 100 suns. So that is how the solar masses can be described in that. It is a unit, right? So that is how it goes. One solar mass is our sun. You can compare those others in point. You can, below it, it is 0.0001, it is 0.1, then 1, then 100, and then 10,000. So main sequence stars, and this is how it goes. And the x-axis, it is having temperature in kelvins. So our sun is having approximately 6,000 Kelvin, right? So now let me ask you the question. The question is, after describing you this particular image, tell me that how do you describe, in what spectral classes you describe this particular diagram, and what is the name of the diagram? This is my question. These are two questions actually. So yeah, anyone who is interested or knows the answer, please raise the hand. Anyone?
Or if you are not comfortable in unmuting the mic, kindly type in the chat box also. It's also fine.
Yep. And if you don't even know, you can just tell me. I can explain it more in a detailed manner how it goes.
Yes. If you are right also, if you are wrong also, kindly proceed. It's no issues.
No worries. We are all here to learn. Even I
Yeah.
am learning. It's just a part of learning process. We are all learning something different apart from your
Yes.
school syllabuses or college syllabuses, whatever it is there. Repeat the question. Okay. So my question is, what is the name of the diagram first of all, and how do you describe the spectral class? In what abbreviations does you describe the spectral class? Yeah, please. Sanjay Chawla has raised the hand. Please open your mic and go ahead.
Yes, Sanjay. Yes, Sanjay.
Vaibhav Baldani. You can also,
Yes.
yeah. Hello.
Yeah, am I audible?
Yeah, please go ahead. Answer your thing.
So it is an HR diagram which classifies at which stage the star is. Is it in the stage where it end up its whole fuel and converts itself into a white dwarf, or like that, like white dwarf or red giant.
Okay. Do you know the full form of HR? Can you tell everyone what is the full form of HR?
I think it's Hertz. I don't know the H, D's Drustil or something like that. I don't remember the name right now.
Okay. No worries. Do you know the abbreviation which is there? Like, there is some abbreviation you can describe. Every spectral class is having some abbreviation like OB or something. You might remember.
No, I am not aware of the abbreviations.
Okay.
Like,
No worries. No worries. Great. But your answer is right. Great. So, okay.
Yes. Next. Anyone knows the answer? Soham? Soham?
Oh, sorry, my mic was off. I was
Yeah.
distracted. Okay,
Yeah, yeah.
so okay, so let me tell you like what is exactly this diagram is like. Um okay, so this is exactly the way how it goes, and exactly the way how it described. So this is HR diagram, Hertzsprung Russell diagram. Okay, and basically it describes that how the lifetime of a star functions. The blue stars which are there. It is the most hottest stars, and it is like most luminosity. The most luminosity of the stars is there. So and those stars are having a less amount of lifetime because they are having more luminosity. So they end up their fuel very early. It's just like that you have filled 1 liter of your of your this vehicle. You have filled 1 liter of petrol in your vehicle, and you are going like you're wasting those fuel, and you're going with a speed very high, so it might burn early. So it's just like that. That concept is same followed here. So that's how it goes, and this particular graph, it describes the spectral class of the star in abbreviation format, in the it is having some letter, some letters are actually described, or they are gifted. Those temperature are having some letters, so those letters, it's like O, B, A, F, G, K, M, right? So now what the hell this is now? So O, B, A, F, G, K, M is actually, it is like, for example, let me tell you this. In the x-axis you can find the temperature, right? So it is having 30,000 kelvins. 30,000 kelvins, you can find that it controls the category of O. Now the sun, which is having, it is under OBAFG. G category is for sun. So now that category is described to the sun. Those kind of stars, all the stars which comes under the temperature or luminosity statistic wise comes under or comes with the sun, it is gifted into that particular category. It is put inside those categories so that it will be easy for us to describe or to segregate those stars accordingly, right? Now, in the main sequence stars, you can find this. There are white dwarfs, which are also having this type of category. There is also a category for supergiants, giants, and hypergiants like Betelgeuse and all. You also might know the name of UY Scuti or Aldebaran. These all comes under the hypergiant, star categories. So these are some things which you should know. So now I said some letters, a format of letter or a set of letters, O, B, A, F, G, K, M. So now I didn't wrote it anywhere, or I didn't needed a note to remember this. I just remember it that way. So let me tell you that this is a bit funny for you guys. How do I remember it? There is also this is also a thing which is described by scientists. You can actually search it on Google and you will get the results. OBAFGKM, this particular set of star categories or spectral class of the stars, this can be remembered as O, be a fine girl kiss me, or for girls it is O, be a fine guy kiss me. So this is how the way you remember these things. You can literally search it on Google. It is like available everywhere. This is how even the most biggest scientist, or even Carl Sagan, has remembered this particular thing with the same description way. Okay. So now I hope I'm clear with you all this particular thing. And okay, now let's go to more some interactive things. Let's get you guys more some descriptive things of the conceptual astronomy. Now let's go into cosmology. Now, what is exactly cosmology? Okay, I will ask you your questions or your doubts afterwards, but let me tell you what is exactly cosmology. Now, cosmology is nothing but astronomy only. Okay, it's just, don't get into, first of all, if you're interested in astronomy, please, I will request you all that don't get into that Greek names and Latin names, and it is described from this, like astronomy is from astro and nomy and all kind of things. It is just like, if you want to read it, then read it, but if you find any person interested in those kind of things, please get away from that person immediately. Okay, don't get into those things. So now cosmology is basically a Greek word which comes from KOSMOS, cosmos, right? So cosmos means basically the world, or the universe, which I mean to say in my references. So now I actually put it this topic, introduction to cosmology, because I wanted to tell you all that how exactly there are some things which are still unanswered. We all say that there are so many things which are discovered, and there are so many things which have advanced in data science and structures and AI and whatnot, chat GPT and all those things. We all have got at a certain level where we have nothing or no particular aspect for the innovation or something or invention. I can understand those things, and basic things have been developed a lot. But to be honest, if you want to do something which boosts your curiosity or satisfies your curiosity, this is the perfect branch or the field to get inside it. And that is how I will actually encourage each and every person to or each and every brother and sister of mine here to just pursue this field and do something of your own interest into this field. Okay, now let's get back to the topic. Introduction to cosmology. Now you tell me, what is exactly you have learned in cosmology, right? Or what is exactly you think cosmology is? If you want to describe it in 2 lines, you can go ahead. If you want to tell me anything by opening your mic, that is also, you're most welcome to do all those things. Okay. Anyone want to say anything? That what is exactly cosmology according to you, or how do you? What are the exact things that you got interest in cosmology or astronomy, basically? No one? Okay, no worries. If that is the study of the cosmos in which we all exist. Yeah, that's true. That's true. It's the study of the cosmos. Yes, it is study of the known universe or the known world to us, which is there, and known world to us, and we study those in depth, or we get to know more things about it. So this is how exactly the basically those basic things are there. In the depth, there are so many things, and cosmology is interconnected to theoretical physics, which is one of the most hardest formats, and even was hard for my personal hero of theoretical physics, Mr. Richard Feynman. So he was also a very big fan of quantum mechanics and theoretical physics and all kind of things. And he described that it is even hard for me. So if that particular person who gets a name, who got some a Nobel Prize in physics, especially in quantum fluctuation and all kind of things in that particular field, and he's saying that it is hard for me, then we have nothing. We don't even know 0.001% of this particular things. Okay, so now let's get it back to the topic, and let me tell you that how cosmology is to me now. Or what is my experience regarding cosmology, or since the very start when I was young and I wanted to pursue astronomy as a career field or something. So cosmology is basically, according to me, it is something which we study around us, and everything which is there. Cosmology is having, first of all, cosmology is a science, and science consists of three things: physics, chemistry, and biology. Cosmology is also having those. If we consider that cosmology is a synonym to astronomy, then astronomy is also having astrochemistry, astrophysics, and astrobiology. So all these things, all these small things are there. These are all considered into cosmology or astronomy, and there are basically each and every field of electronics as well, CS as well, data science, blockchain and whatnot, and AI and AR and VR, all kind of things are there inside astronomy. So that is why these are some things which we should consider while taking or while pursuing or while thinking about these things very seriously. Because civil, mechanical, these things which are not having any scope in India right now, or it used to have a lot of scope earlier or 20 years ago. Now it is not having anything, or the people from India are going to Germany or something else countries to pursue more MS in mechanical and all kind of things. So they can think of this particular field, because every field or every branch or every sub branches of science and fundamental application sciences are connected to astronomy and cosmology. So yeah, these are the things. Next thing which you can see on the slide, it is having a small pic, not small actually, considering it is having the whole slide, so it is deliberately I have put it there. You can see that the Big Bang expansion and dark ages and inflation and quantum fluctuations and many things are there. So what is exactly this? So this is actually a time map or a mind map, how universe got cooled and how universe is today and how it used to be earlier. Now you can see it there that in the starting of the very big flash is there, that is Big Bang for sure. Okay, and after there is a greenish, bluish and yellowish or whatever is the color combination there is on the slide. It is something there. Now, what is exactly that? That is actually the CMB, the cosmic microwave background, which happened just after the Big Bang, and it was the cause, or it is the proof, which is which is the proof for the a very big proof for the scientists that Big Bang really occurred, and that is how the universe is now today. The first star you can see 400 millions ago, whatever is there. But we are interested in not this. We are interested in the very start of the universe. The quantum fluctuation part, which is there. It is like we are still unknown to the fact that what exactly those two materials were that caused the Big Bang. Did Big Bang happen eventually, or did Big Bang happen because of a certain phenomena, or it was destined to happen? So these are some questions which occur in my personal mind regarding Big Bang. So if you have any answers or something, you can mail us, you can tell me right now as well, no problem, or you can put it on the group or something. Okay, so that is how it goes. Then the dark ages comes. The dark ages is the part This part was where universe was only having gas clouds, the gas clouds of helium and hydrogen. These were the only things which were there during the very start or the very initial stage of the universe. Okay, so after that dark ages, first stars came, and then the development of galaxies and planets, and everything happened. So now you can see that universe is accelerating. The cone is there, which is expanding, going on expanding, and the universe age is now 13.7 billion years ago. But I strongly disagree to this. The universe age is not 13.7 or 13.8 billion years ago. It might be more. That is what I think, because the observable universe is very small. Our vicinity of area where we observe or do experiments on the telescopic part, it is very small. So we exactly don't know this answer on the observations of us. We are thinking about this particular things, but yes, I do think that our eyesight goes to 10 meters doesn't mean that after 10 meters the world is ending, right? So that's what my particular perspective is regarding this. Our eyesight goes till 10 or 11 billion years ago, so that doesn't mean that Big Bang started there only. So that's how it goes. Let's go more. So these are the key problem challenges. Just few minutes ago, I was telling you that today's world we say that there is nothing we can do more. These are some key issues which you can find, and if you find the answers to these questions, I can guarantee you Nobel. So that is how it goes. Let me read point by point, and I will describe one or two lines only because we are having some time restrictions. So we need to get this. We need to end this soon in 15 minutes. Okay. So what is the exact fate of the far future universe exactly? So now there are three possibilities according to scientists, like big crunch, and there might be vacuum annihilation, where all the vacuum will it will burst, the vacuum the vacuum which is present in the universe, it will not be there, and it will just tear the fabrics of space time, and it will cause the destruction of the universe, and again it will cause big bang. So big crunch is there, big wrap is there, and vacuum tearing apart is there. So these are three prospects how universe can end. This is the fate of the universe. But let me tell you this. According to string theories, or if I say that super theories, general relativity theory and all. So there are three prospects which how universe might end, but these are also things that many scientists say that after destruction of the universe, the creation of the universe will always happen with Big Bang only. Again, so basically, universe is a loop, which is how it's functioning. That means we are a loop as well. That means there might be more dimensions to the universe which we don't even know, or which we don't are even aware of. So these are how the things goes. Did the universe have a beginning? Indeed, because universe was having a beginning. That is why we are many atheist scientists say that God don't exist. I will not go into that debate, but I'm just telling you that why since we have got the proof of Big Bang, Stephen Hawking has really got into the debate that why God isn't there, because he said that he knows that God isn't there. And I have been through each and every book of his since last 2 years. I have read 6 or 7 books of Stephen Hawking, and I have really agreed to this part of his. And we will debate, or we will talk on this particular topic, particularly this topic. Some another day, because this will take 1 hour or more than even 1 hour. So yeah, let's get to the next point. Underline, this is the physics horizon before the beginning. What is the origin of arrow of time? Just the time didn't existed before Big Bang, because the universe was so dense, or it was in the singularity. You know that what singularity is. Singularity is the point where volume is zero and gravity or density is infinite. So that is how the singularity can be described in 2 or 3 words: zero volume, infinite density. That's all. So time existed after the Big Bang itself. It was not existing before before Big Bang. So this is the theoretical part, and this is actually a very big mathematical calculation. What I said just now in 2 or 3 lines I described. This is a hell lot of mathematical calculation going on. Okay. Now let's get into some phenomena, some theoretical physics phenomena, right? So does general relativity break down in the interior of black hole due to quantum effect, torsion, or some other phenomena? I can say this is also a theoretical phenomena or theoretical physics part, but in one word, or which I want to say, there are some things which are unknown to us, and general relativity, quantum mechanics laws also breaks down at the singularity or even in the Einstein-Rosen bridge. So at that particular phenomena or that particular amount of time, the laws of general relativity or even the quantum fluctuations goes off, right? Supermassive black holes, the formation of high redshift quasars. What is quasar? Quasar is also a part of black hole itself. When the black hole can't suck the normal matter more inside, and it forms the plasmic disk around itself, right? We call it accretion disk. We call that disk accretion disk, and due to the extreme friction between the particles, plasma is generated, and because of those quasars are formed. Right, so that is how the high redshifts are formed, and black hole information paradox and black hole radiation. Now, black hole radiation is a hell lot of big topic. There are so many things described by Stephen Hawking, which black hole radiation tells us. Now, black hole information paradox. There are so many paradoxes. First of all, there is Schwarzschild radiuses. There is there are event horizon paradoxes are there. There is like spaghettification is there. So these are many things which are included inside the information paradox. If you find each and every question answer to the question in even a theoretical way, maybe you will have a very good life. But after your death or something, you will get a Nobel. If you get before your death, if you get a Nobel before your death, it's destiny and it's a really great thing. But these things are for sure the most challenging aspects in cosmology, in the branch of cosmology, I will say. So now, next, I will go to the next slide. It is only having the next slide is us. I have created a certain Hall of Fame for the Indian astronomy, which is right now going on, because I don't like to make PPTs in paragraph manner or something. It is just like a childish manner it is. So I just try to do something innovative or something different. So you can read the news which are there. You can get that right now. You all know that ISRO successfully launched 36 OneWeb satellites in orbit. ISRO and NASA is having NISAR kind of program, which is to develop the remote technology, remote sensing technology or radar technology in India, and it works on dual frequencies and having each and every frequency, UHV, VHV, VHF, UHF, and all kind of things are there. So then you can find that AstroSat has done a breakthrough and other countries are really looking forward to collaborate with ISRO or other private space agencies. To be honest, private space agencies, let me get to this point. Private space agencies in India are developing at such a rapid pace that after 4 years or after 5 years, I think that MNCs will be the local private space agencies itself. Just like Laksha Space is there, just like EdTech platforms are there. You might have heard about this Agnikul, this Skyroot, or even Bellatrix, which is there. It is collaborating with ISRO on a very big levels now. I heard just today itself from my source. And Skyrocket and Agnikul are leveling at such a platform that they are developing many kind of rocket propulsion fuels, even some methane fuels they are developing. They are developing organic fuels, to be honest, so that the pollution which is caused by the rocket propulsions or the rocket launches can be decreased on such a level. And you all have heard about SpaceX for sure. Who doesn't know about Mr. Elon Musk? So these are some things, or these are some formats that how private space agencies are getting a pace, and those private space agencies require each and every guy from each and every field. Then it doesn't matter whether you are from CS or whether from electronics or whether you are from mechanical, civil, or even if you are from aerospace branch, right? So these are some things, and look forward a lot to you all guys who are interested to get your way through this particular thing, because right now is the chance where you can do something and make your ground or your base a very strong, or you can make your name inside the corporate sector of private space agencies. So I give you all a hell lot of chance, or I want to open this up all in front of you, that Indian Space Astronomy, which is there, not just ISRO, because it is a government organization. It comes under the Department of Government of India of Space and Defense Department of India. So these are all having a very big things, and ISRO is not the alone. It can't alone. Organization can't do any big breakthrough in particular field. It always needs either private space agencies or other collaborative fields with other universities which are outside, or even inside the countries like IITs or NITs, or even ISC Bangalore is IISG is there, or even NASA is there, or JAXA is there, or Roscosmos is there. So all these things are there which you need to think in a very vivid manner, and then you will get that how exactly things perform, or how is there a certain way to do certain things, right? So you can have a visit to laboratories, observatories, and you can make your name everywhere by doing something, or small things are also there which will make not just your resume. And I will not concentrate on your resume, because if you do your things on the basis of your curiosity and to do something, your resume will be formed very good. Just now, if you are doing something, even if you are 18, even if you are 17 or 16 or 15, it doesn't matter. You can start from 15 itself. I personally started from 14. I was having curiosity since second grade. So you can do something, right? Just try to do something. Just don't say that you don't have opportunities, or it takes on a very big level. Satellite is you require a very big money or something. Just start from the smallest level. You'll get to the biggest level, and you won't even know. You will just look back and you will say, I just did something. So just do something, and I wish you all the best. And yes, so let me give you more overviews on this, how ISRO have developed. Now ISRO, you all know that ISRO's journey has been a very terrific journey since 1969, right? So it started with a cycle launch of a particular rocket, and it was all due to APJ Abdul Kalam, Mr. APJ Abdul Kalam, the 11th president of India, and our really beloved scientist Vikram Sarabhai. So these are all the scientists who made India a really great thing, or into a very great nation, or especially made ISRO onto a very great nation, right? So Chandrayaan 2 was a partial success mission. Chandrayaan 1 was there, and Mangalyaan was there. Chandrayaan 2 happened. Now Chandrayaan 3 we are also looking at Gaganyaan in the future. We are also looking at a mission of Sun, which is to the Aditya L1 in 2022. Which is actually now, it is now postponed to 2024. MOM 2 means Mangalyaan 2 is also there. Venus mission is also there. Lunar explorations, exo worlds, and even these are all some roadmaps, or the future roadmaps of ISRO, how to perform, or the missions till 2028 or 2030. So man on the moon is there, man on the Mars is also there. So yeah, regarding this rocket propulsion technology, if you are more interested in rockets and engines, or scramjet or ramjet, if you have heard of these things or these words, then you all know that we started from SLVs, satellite launch vehicles, then we got to the ASLV, then we got to the PSLV, which is currently also working, and GSLV is also there, which is going on right now. I think today they tested some thing with PSLV, and it was a breakthrough as well. You can go through news today. I think PSLV testing was there. GSLV Mark II was there. Now Mark III is the most indigenous developed engine, or the most powerful, or the big brother of India, which is GSLV Mark III. So RLV-TD is the next future missions which we are going to undertake. RLV TSTU means recyclable launch vehicle, just like SpaceX, just like Falcon Heavy and Falcon 9. So these are some things which are going on in the private sectors or in the government sectors of Indian astronomy, and this is how it is functioning. We're also having laboratories, and Asia's second biggest laboratory is in India itself. We're having biggest laboratory in Nainital, and even in South, I think Kavalur or something, we are having laboratory telescopic. We are having very big telescopes. We are having, and it's a very gratitude thing that India is having a really good ambitions towards space astronomy and satellite technology, right? So yeah. So let me tell you basically now. Let me give you a basic overview exactly who we are. Now, if you are a good person if you know these things, or what I have written in the slide, we are Astronautic Institute. We are a legion. We believe in the universe, and please expect us in the future, because we are going to have some really great aims or prospects, or even in the future we are going to have a real good missions in the or visionary plans we have discussed, and we are going to undertake those under Laksha Space, under many more collaborations, and universities and all kind of things, and we have started those things already. So let me tell you this, just for knowledge thing, this particular line or this tagline This is actually a tagline of Anonymous Group, which is cyber security group, which is there, the best cyber group in the world, Anonymous. So I have taken those copyright from these things or those people, to be honest. So now let me tell you that how we are going to make your future and also the future of India in the coming years or in the coming decades more, more. Sorry, more visionary or more clear, how we are going to make it crystal clear to the people of India that astronomy is not just for hobby or passion, it is a real serious career and you can do something in it. So now let me tell you what's in it for you. What is exactly your benefit? Why you should be a bit selfish, right? A bit selfishness is always considerable. You should be a bit selfish that what is exactly in you, because you shouldn't think that I am doing good but I'm not getting the results out of it. So let me tell you what exactly we have all these things in you or we are going to offer. So internships are there. We are going to provide many internships, not just on CubeSat technology, not just on rocket purposes, but also on drone technology, which is right now grabbing a real pace in Indian markets. Not just in defense sectors, but also in commercial sectors or even in marriages we use the drones. So these things, that is a big hell lot of scope is there. There is a very big gap or the loopholes which you can fill, and you can do those internships there. You can always come to us and let us know that hey, I want to do some internship, I want to learn something, and that is how we will go. If we can provide paid, unpaid, any kind of internships are there. There are many prospects. You can just come and we will discuss all those things in private manner as well as a professional things. So now guidance sessions and convocations. Now this kind of session which I just took right now, there will be many more guidance sessions, yes, many more convocations. We will tell you that exactly. We will give you recent or everyday news in the of the every article will be sent to you every evening or night. Just now, since last 2 or 3 days, Dhanush sir is sending many articles that what is exactly today, what is the exact updates of today. So you should update your knowledge. I can understand. You will not read every article. You will just say, "Oh, there are some links I will not even read." So don't do kind of things. Just open one kind of link or just click on one random link and just go through just read the headline itself. Don't read the whole article. Who told you to read the whole article? So even if you read the headline, you will get to know that what is exactly going on. And if you don't understand, automatically you will start to read the article that what is exactly this, I didn't even understand what is going on. So that is how it goes, and many more guidance sessions and convocations are going to happen, and on different topics. This is just the three topics. I will take more guest lectures will be there on more deep topics. This was just a basic topic that what is exactly the universe is all about, or to more updates, or to just to make your knowledge more clear or vivid manner. So this is the session. This is starting session, right? So baby steps we will take, and more good sessions will be there, like on quantum chromodynamics, quantum field theory, general theory of relativity, M theory, extraterrestrial life forms, or Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, what is exactly going on, Pluto or Planet 10, Planet 9, how exactly these things are going on, and masses, solar masses, or even black holes, which is your favorite topic. I know, because every person who is enthusiast, black hole astronomy enthusiast, is having a very special place in the heart for black holes. That is something I know very well. Next, DGCA official license. This is actually for the glider planes, the people who are into glider planes and all kind of things. You will get an official DGCA, which is like a directorate for the aeronautics, which also is the main head for AAI. Airports Authority of India is also the handling of AAI is DGCA. So you will get an official license. That is a very big thing for the people who want to do something in this particular field. CubeSat kits. We are also soon going to launch the CubeSat kits, and you can buy those kits at a very cheap price. Now you all tell me that satellites are having crores and crores of rupees and funding. CubeSat, you can get those CubeSats below 5,000 itself. I'm saying below 5,000, we will launch it in 3,000 itself. I'm telling you. Okay, so you can order those CubeSat. We'll have workshops in it, and you will get a hands-on experience on CubeSat and how you can be satisfied. You'll get certificates, valid certificates, which you can put it in your resume in the future, or even if you are on LinkedIn right now, you can put it there. You can share it. You can just tag us. You can let us know what is exactly going on. You can share it with your friends. You can just flaunt your certificates or your CubeSats in front of your friends that I I did something and you didn't do anything just but just academics. So you can just do like that, just giving an overview. Workshop and hands-on experience of satellite drones and many more. Grab the certificates, grab the opportunities, offer letters, letter of recommendations, offer letters, and many more things are there. You can just get it, internships you can get stipend and all kind of things. So there are many more things. You'll get an experience that how this corporate world functions. If you are going to work it in future, why not to just get experience on this? And even if you are a part of this company or this particular edtech platform known as Astronautic Institute for even 1 or 2 years, and if you at the end of the year you will tell me that hey, so I want experience letter or something, and due to some circumstances I am not able to continue, I want experience letter for 1 or 2 years. That is also a very great thing. You're already having experience letter for 1 or 2 years before having your graduation or your post graduation. So that is all everyone requires. Before, after graduation you all do 1 or 2 years of jobs. So that is how it goes. And if you are having experience very early on in your life, that is just like a icing on the cake. So satisfaction that you will be doing something productive at the end of the day, when you are on the bed and you are going to close your eyes, you will have something satisfaction that I am literally doing something. And let me tell you, Laksha Space gave me that exposure or that particular boost to my knowledge and my talent, that that I did something productive, and they give that exposure, that opportunity. They were really considerate, and the working environment is really good. So that is why that's all I can say for now. And literally, whenever I do something for Laksha Space or even something else, I'm also a member of 5 different space organizations or tech platforms, right? So whenever I do something, anything else in the field of this particular astronomy or at anything, at the end of the day, I literally feel that I did something productive, and that's all I want in my life. For now as well, to be personal, right? So now let's go to the next questions. Any questions for you guys in the whole session? If you have any question, if you want to know that how are you going to go, how are you going to undertake task or something. So any questions you have, you can right now ask me that how this particular company is going to function, how we are going to get opportunity or something. Then let me know whatever your questions are and how it is going to go.
Soham, there are some questions in the chat box.
Yeah, I have started. I'm going just reading those questions itself. It's informative. And thank you, Sandeep. Thank you. It means a lot. Even a small compliment from you all, it's a very heartwarming thing for me. Okay, please recommend books for beginners by Stephen Hawking. Okay. One of my favorite questions. Okay, so Stephen Hawking has been my mentor, first of all. Next, you can read Theory of Everything. You can read Grand Design to go into the depth of the conceptual physiological part of the universe. You can read Big Answers, Brief Answers to Big Questions. It's a really great book. This was the last book by Stephen Hawking. I have read those books personally. Just when Mr. Stephen Hawking died, I bought the book instantaneously or pre-ordered that book actually. So that book was really, really well, because all the questions or all the cosmological questions which we discuss or I discuss right now, that these are some very great part, or these are having some very interesting part, or some suspicious part is there which is not discovered till now. So you can get those answers to those questions in those book, especially that book of Stephen Hawking, which is Brief Answers to Big Questions, right? And you can go like the starting, which is there. The start book is there for the history, or the start book, which is literally like very common book of there. It is Theory of Everything is actually a picture as well and a book as well, but I recommend the book. That book is really, really very informative, and the great thing part is there that Stephen Hawking always tries to maintain those questions or those answers to the questions he gives is laid in a very descriptive manner. So that is how I will recommend. There are more books, that Universe in a Nutshell. I have been reading that book really since the very start. The Universe in a Nutshell, the briefer history of time is there. And there is one BBC document actually. There is one magazine Right. I actually ordered that book. I thought it is a book, but when it came, it was really very thin. It was having like a 25 or 30 pages book. It is. I highly recommend those books to you. The people who are black hole enthusiasts. You can just take that book, that magazine actually. The black holes, the Reith lectures from the BBC documentary. You can just search it on the Amazon and you can just buy it. Brief History of Time is also there. That I will recommend everyone reads that book. Even if you are not an astronomy enthusiast, in every house I will find that book, that Brief History of Time. Sorry. So now let's go more into the next question. Hi, I am 15. How do I attend the other sessions and other opportunities like internship? So stay connected to the Astronautic Institute. I highly recommend this institute to you. If you have any doubt or any other, like if you want to grab the opportunities which I told you in the previous slide, like this kits and workshops and guidance sessions and convocations, every opportunity, every update, you will get it on the Astronautic Institute group, on the WhatsApp group or the community group. And please do subscribe to the Instagram of Astronautic Institute, and also on the YouTube channel which we are having right now. The YouTube live is also going on. So if any doubt you are having, people on the YouTube live which you are, if you are viewing this, if you have any doubt, I request Vishal sir to put the guideline, community guideline link, WhatsApp group link in the description. So you will find the group link in the description and you will get instant opportunities. Also, there is a Discord server. The Discord server link will be sent to you after the session in the group itself again. And soon I'm personally thinking to also launch a Telegram group as well. So this is how you will get, and you will get also more edtech platforms information, that if you are having any competitions or something, if you are having convocations, workshops, you will get the updates, regular updates on the group itself. And if you are all having any doubts, or you want to email, if you want numbers, I know every recommendation or numbers are really very important in this age. So here is the number or the contacts. You can take a screenshot, or even if you want, I can send the PPT in the group afterwards in the session. Deepak sir is there, he's the founder. Dhanush sir is there, he's a co-founder. I am there, Soham, and our email ID is also there. You can anytime email us. Vishal sir will guide you through Instagram and Gmail as well. So yeah, so that is all for now. If you have any more questions, I will stop for 5 minutes. If you have any more questions, you can just know how you can just ask me those questions right now, or you can ask the question later as well in the coming sessions. I will be there itself. No worries at all. Vishal sir have sent the link in the WhatsApp group in this chat, and also his number. You can contact him as well. No worries. So yeah, any questions? I'm giving 2 or 3 minutes to you guys.
No questions for now. Thank you so much.
Thank you, Raghavendra. Thank you very much. So okay, I hope that this was all for now.
So,
Yeah. Please take it forward, Vishal sir. Yeah.
yeah. First of all, thank you guys. Thank you for spending your valuable time with us. Yeah, this was the first step towards the study of the huge thing that's called astronomy, which was really and brilliantly conducted by Soham. Soham, I would like to thank you for conducting a wonderful session.
Thank you, sir. Thank you very much. Same
And
to you
guys,
for really thank you for Vishal sir for coordinating with me, and also for support of Laksha Space, and Deepak sir and Dhanush sir.
yes, Soham. And guys, if you have any messages or any queries, I have pinged my number in the chat box. You can take a screenshot, you can copy it, or you can save it. Or Soham, you can just show that previous slide also. Yeah, you can take this screenshot, or you can take this anything with whatever way you're comfortable. You can take the details, and anytime any doubts you have, kindly ping us. So we are available 24 into 7, and we are there to help you all. And guys, any of your friends, or any of your friends from any state or any place, who are the space aspirant, who have a huge interest on space and astronomy things, kindly share this WhatsApp group link, so that they can join, and they can also contribute in a huger and greater way to the astronomy sector. Okay. Uh, Guys, you have like 10 seconds to take the screenshot. Okay. So I hope everyone have taken the screenshot. Yes. So finally, thank you guys. Thank you all. It was really a wonderful session. And further more updates of the regarding the Astronomic Institute, you'll be getting in the WhatsApp community. So as of now, thank you guys. So yeah, so it's done for the day. Yes.
Sure. Thank you. Thank you, everyone. You all may leave. That is all for now. Thank you.